Anytime Maritime.
Anytime Maritime. It's Anytime Maritime.
Good morning everyone! Magandang umaga Pilipinas and welcome aboard another episode of Anytime Maritime. As usual, ako po si Mary Ann Pastrana at ngayon po we are going to play a very special recorded live stream of a conference with a powerful theme anchored in excellence, the new era of Philippine maritime innovation. As our maritime industry navigates through uncharted waters of modernization, sustainability, and global competitiveness, we're here to explore how Filipino excellence continues to lead the way from breakthrough technologies to progressive leadership and green initiatives. We're setting sail into a future with purpose and pride. So, sit back, stay tuned, and be part of the wave of change shaping the future of maritime in the Philippines. Alam niyo naman po, dito sa Anytime Maritime, bit-bit po namin kayo sa lahat ng mga ina-attenda naming mga conferences at sana po marami po kayong matutuhan sa mga conference na piniplay dito sa Anytime Maritime. Again, this is Anytime Maritime where every conversation sets the course for progress. Thank you for being part of Anytime Maritime and continue to keep in conversation with us, intelligent conversations here at Anytime Maritime. Enjoy!
On behalf of the administration as a recognized organization, please welcome Mr. John Paul DeWill, Senior Technical Manager of Asia Marina.
For inviting Rina to present at this forum. I will be putting EDI and EXI in the perspective of a classification society as well as recognized organizations. I think it's unavoidable that there will be some overlaps with the previous presentations, but I think it's important to also to understand it from the perspective of the classification. This has been shown before, but what has not been specifically mentioned is that in 2016 the Paris Agreement came into force, and this basically forced member states, countries to fight climate change, the threat of climate change. And as shipping as an industry was not a country, it was not part of this Paris Agreement. That is why IMO actually took the initiative to fight climate change from an industry perspective. So in 2018, IMO adopted the first greenhouse gas strategy, which was revised in 2023 and became more stringent. The initial greenhouse gas strategy mostly focused on carbon dioxide and CO2, but in 2023, during the revision of the strategy, also the other greenhouse gases such as nitrous oxide and methane came into the picture. The current end goal of IMO is to be net zero by 2050, by or around 2050. So not only CO2, but also NH3 and N2O. So the initial greenhouse gas strategy only focused on CO2, and at that time IMO actually introduced short-term, medium-term and long-term measures, because IMO realized decarbonization, the energy transition cannot be done in one step or with one measure. So the short-term measure and the medium-term measures can probably be achieved by existing technologies and operational improvements, but the end goal being net zero by 2050 will probably require alternative fuels, low carbon and zero carbon fuels. But in this presentation, you can go to the next one. So in this presentation, I will specifically focus on the short-term measures, which will span the time frame of 2023 to 2030. It has already been mentioned that the EDI was introduced in 2013 and that it was introduced in a number of stages. So the energy and efficiency index regulates the energy efficiency of ships. And by just regulating the energy efficiency of new build ships, there would be an uneven playing field. So IMO, during the initial greenhouse gas strategy, also introduced an energy efficient index for existing ships. So we will not be talking during this presentation on operational measures, CII, which has been mentioned in the first presentation, which is part of the SEM. The EDI has been duly attended to by the presentation of Engineer Ray. So I will also not touch in detail on that, but more specifically on EXI. So the aim of both EEXI and EDI is to quantify the vessel's technical energy efficiency. So it's not an operational index, but it is a technical efficiency index. And the idea is to benchmark all ships fairly against each other. And then this is about ships of the same ship type and the same capacity. So the current EEXI framework for international shipping is applicable to existing ships of 400 gross ton and above, and specifically engaged in international voyages. So the ship types which are mentioned here, the four ship types are excluded, and of course also domestic shipping at the moment. The EXI is a one-time certification, so all ships which are within the scope of EXI should have been certified by the end of 2023. It was mentioned in one of the previous presentations whether existing new ships would also have to be EXI certified, and I will come back to that later on, why that might be potentially the case. So this shows in a different representation what has been mentioned before. The EDI framework has been introduced in stages from 2013 onwards, and you'll see now that we are in 2025, and all the ship types within the scope of EDI are in phase 3. IMO has introduced EXI as a single phase measure, so for now there will be no strengthening of that framework, but IMO is currently reviewing the short-term measures, and it might be the case that IMO decides as early as next year already that there will be a second phase of EXI or a fourth phase of EDI. The formula of EDI has been shown before. The formula of EXI is not much different. There are slight and minor differences for which unfortunately we do not have enough time to discuss. Don't be too distracted by the complexity of the formula. There are consultants in classification societies, shipyards who can calculate this for you, who actually have established software to calculate the attained EDI or EXI for you. In its basic form, the numerator defines the emissions of CO2, the denominator defines the transport work. In its simplest forms, it's engine power times the CO2 conversion factor times the specific fuel consumption. The transport work is the capacity of the vessel, either in deadweight ton or gross tonnage, times a reference speed. Beside the attained EEXI, there is also a so-called required EEXI, and that follows the same principle as the EDI, which was presented before lunch. So all ships below 400 gross ton, which are required to calculate the attained EEXI, but there are some differences in ships and ship types which are required to comply with the required EEXI. The required EEXI is derived from EEXI reference lines, and they in turn are derived from EDI reference lines. As in its simplest form is represented in the chart here on the right side. The blue line shows the EDI or EXI reference line. If your ship, if your attained EXI value is above this line, your ship will not pass. If you're in the green, one of the green ships, then the EEI will pass. For the ships on the left side of the cutoff line, there is only a calculation required, and those ships do not have to be compliant with the required EXI. This has been explained earlier today in a different shape and different form. In the run-up to 2013, when IMO introduced the EDIR, they have made a statistical analysis of all existing ships, and based on that, they have derived phase 0 of EDI. So made these reference lines with the clear intention that as each phase progresses, those reference lines will become lower and lower. Meaning to say, let me just go back to the previous slide. One more back. So this blue reference lines will become lower and lower, meaning that ships will have to introduce more and more energy efficient technology in order to comply with both EXI and EEDI to an advance. As many items in my presentation before they have been touched upon, again I will just highlight it from a classification society. So since 2013, new build ships have been subjected to EDI, and the calculation of this EDI would have to be documented in an EDI technical file. This file is in principle a statutory document and will have to be approved by the administration or the recognized organizations on their behalf. So all ships within the scope of EDI will require an EDI technical file on board, and that is an approved technical file on board. Likewise, there is an EXI technical file which documents the calculation of EXI, and this will, as mentioned before, prepared by the owners or the ship managers or alternative consultants on their behalf. Also, this document is generally approved by the classification societies as recognized organizations, or a small number of administrations who will do it themselves. As I mentioned, EXI was a one-time certification, so by the end of 2023, all ships within the scope of EXI should have been certified. Of course, there is always a small number who misses this deadline and still pending, actually to this date, pending certification. But that on a side note. You would say that ships with an EDI technical file would automatically comply with EXI, but that is not the case, as already intimated by the representative of the shipyard. So ships which have been built according to EDI phase 0 might not necessarily comply with EXI. So they still would have to take improvement measures. So for those ships with an EDI technical file, the owner has to check if the attained EDI is below the required EXI. If that is the case, if the ship is in the green zone, there is no requirement for an EEI technical file, and the administration or the class on their behalf can issue the International Energy Efficiency Certificate. So if the ship is not compliant, although the ship has an EEDI technical file, the ship has to follow the procedure as if it was a non-EEDI ship. I mentioned the IEC, and this is actually the document where all the values of the required and the attained EDI and EXI values are documented by the administration or the class. So this is a scenario for ships without an EDI technical file. What those ships needed to do prior to 2023 is to calculate their attained EEXI. So if this attained EEXI is below the required EEXI, there was no issues, and the administration or RO could issue the certificate as per step 5. Now, if this attained EEXI was above the required EEXI, so to say in the red zone, the ship owner, the manager, need to do an analysis of improvement options, basically to bring those ships into the green zone. Subsequently, those improvement measures needed to be installed on board the ship and surveyed by the administration or class, and subsequently an EXI technical file, and if power limitation was introduced, I'll come back to that later, an onboard management manual needed to be submitted for approval, after which the new International Energy Efficiency Certificate can be issued. So these are the typical contents of an EXI technical file. It is very similar to what was shown before lunch on the EDI technical file. The only difference is that if there is power limitation introduced, this will be documented in this document and in the calculation. I will focus in on two aspects of the EXI calculation, in which we encountered some issues, which might be worthwhile for you to know if you start introducing EXI and EDI for domestic vessels as well. The calculation of the reference speed, so-called VREF, was mentioned by the shipyard just now. We have encountered that for existing ship, no model tests or no adequate sea trial reports were available, which usually led to some confusion about the value of the VREF. Not necessarily in favor of the result of the attained EXI. You probably know that a lot of old ships do not have all the documentation or adequate documentation on board. We have seen a lot of sketchy sea trial reports which were not done at the right draft or under the right conditions or with the right corrections according to ISO. The IMO guidelines for EXI, however, have a provision if there is absence of this information and that the VREF, the reference, could be approximated with a formula, but again, I would say this was not necessarily beneficial to the result. We encountered the same for the specific fuel oil consumption, SFC. As mentioned before, SFC is usually adequately documented for new-built ships by the makers. Most of the ships which are subject to EDI also have an NOx technical file in which all the fuel consumptions are adequately documented and corrected to ISO values. For the older ships below 2013, this is usually not the case. Those ships do not have NOx technical files, sketchy test reports, so SFC is either not documented or not properly documented. In absence of those reports, the fuel consumptions for both the main engines as well as the auxiliary engines would have to be approximated with default values. And it might very well be the case that in those circumstances, the actual fuel consumption might be much better than these approximations. Now, in the event that the ships ships are calculated with an attained EXI, which is in the red zone, the owner or the manager will have to take measures to bring the ship into the green zone, so to say below the reference line. So there are a number of possibilities, and I have to go back to the formula of EXI. In case of non-compliance, modifications have to be introduced. So you have to either decrease, you have to increase the denominator. So you can decrease the fuel consumption, the power of the main engines and the auxiliary engines, or you increase the capacity of the reference speed. So what is most important is actually on the bottom of this slide. So the effectiveness of improvement measures are not unique. So these options are ship specific and largely depend on the operational profile of the vessel. So if you consider operational or technical improvement measures, you have to look at it from case to case. I will now specifically zoom in on power limitation, engine power limitation as well, shaft power limitation, which are in the context of this topic abbreviated to EPL and shaft body. Do not dismiss the other options. They are technically possible, but as shown on this slide, which is a relative comparison of those measures, engine power limitation and shaft power limitation stands out because it is relatively low cost and it has the biggest impact on the attained EXI compliance. In an ideal situation, we would be looking at the top right, so low carbon and zero carbon fuels, but that is probably not on the radar at this moment. Definitely not for existing ships. So what engine power limitation or power limitation in general does is it establishes a limit on the vessel's main engine power as well as the auxiliary power. In principle, this power limitation should be overridable. So in the case that the ship encounters adverse weather, ice-infested waters, pirate attacks, or search and rescue operations, or any other situations in which the full power is required, the ships with power limitation would have the possibility to override the power limitation. For that purpose, IMO guidelines have introduced an onboard management manual, to which I will come back later, to document the installation and the reversal of this power limitation. So I mentioned that power limitation is by far the easiest measure to be taken to comply with the required EXI, principally because it decreases the engine power by a large extent, and although it also decreases the reference speed in the denominator, but the effect of the power decrease outweighs the reduction in reference speed, because the relation is cubic. Power limitations. I'm not sure if the engine makers will touch upon this subject in more detail, but what basically happens on mechanically controlled engines, the governor will be installed with a stop screw, which will lock the fuel gauge in order to limit the amount of fuel that goes into the engine. For electronically controlled engines, a password-protected software setting will be installed in the control system to electronically lock the fuel that goes into the engine. On a side note, that engine power limitation may lead to torsional and axial vibrations and should be assessed together with your engine maker before you start installing power limitations. So in this picture you will see a small seal on the limitation, and that is actually for the verifier, for the surveyor on board, to check that the the power limitation has been installed and has not been tampered with. This particular example is from Colton's, which is a third-party service provider. But also OEMs like MAN or Everruns, as they are called nowadays, have their own systems with their own sealing. So in principle, when a surveyor comes on board to survey the power limitation, this sealing should be intact. This is an example of shaft power limitations, which requires a bit more equipment on board, a bit more systems. Shaft power limitation is usually installed when engine power limitation is technically not possible. For instance, for twin and single arc gears, for gearboxes with a power takeoff, as well as diesel-electric ships. It involves a torque meter which is installed on the shaft, and some other sensors and electrical components, and a software system. In order to make this system overrideable, there is a password protection which can activate the override so that the full power to the shafts is available again. Now, if a power limitation is installed, either EPL or Chapoly, it is a requirement in the guidelines that there should be an onboard management manual on board. The contents of the EPL and Chapoly is very much alike. It all addresses the differences in the system. There are no strict specific guidelines to the surveyors or the recognized organization who will survey this installation. It is not as it is mentioned here that the time to undo the power limitation should be documented in the OM. It is not as such that the surveyor may ask you to demonstrate this, although not specifically mentioned. It is up to the discretion of the attending surveyor to let the crew demonstrate that they understand the system, that they are familiar with the components. It is a bit easier with shaft power limitation, since that is, as well as electronically controlled engines, since that is software based, to demonstrate that the power limitation can be overridden. As I have shown in the flow charts on previous slides, is the engine power limitation and the shaft power limitation will have to be surveyed before the surveyor issues the international engine certificate. So the surveyor will usually check on board whether the EXI technical file is on board, as well as the onboard management manual, and may ask the crew to demonstrate whether they are familiar with the procedures. But the engine power limitation surveys will typically include a check of the power limitation setting. So the surveyor may check if the mechanical limitation on the governor is set as per the manual and as per the EXI technical file, and may check whether the sealing is intact and has the right serial number. For electronically controlled engines, the surveyor will ask crew to demonstrate whether they know the software password and whether it can be overridden. The onboard management manual also includes recording pages, so in case the crew has overridden the system, they need to record this into the onboard management manual, and this needs to be endorsed by the captain or the master. In case of shaft power limitations, the survey will usually include the checking of all the equipments, cabling and the sensors and other components, as well as the override function through the password setting. Shock power limitations also has a number of alarm functions which need to be demonstrated. The data and event logging in case of shock power limitations, in case of software systems, are probably able to be generated from that system, either on a screen or a printout, and that also need to be demonstrated. So now I'm coming to the second last slide. For those of you who want to have a copy of this presentation, do approach me. My email address is mentioned on the last slide. I have documented the most actual IMO, MEPC, IX and RINA guidelines in the context of EDI and EXI. The links are working in this document, also in the PDF if I send that to you. In general, if you have other questions, do reach out to me or do reach out to our office in Manila, and we can take the discussion from there onwards. With that, I thank you.
Of Rina for that presentation. Before we proceed, let me remind those speakers to remain here at the conference room to serve as panelists during the open forum sessions later after all the presentations. So next, let us hear from an engine maker's perspective for technical file and supply of engine power limit or shop power limit kit and assistance in the development of onboard management manual. Presenting on behalf of Daihatsu Infinite Philippines Corporation, please welcome Mr. Miyahara Tomohiro.
Sorry for waiting. I want to explain about the EXI regulation from our engine makers. First of all, I want to introduce myself. I'm in charge of Philippine Daihatsu Infinite Philippine branches manager. I'm taking care of the Philippine market, and from Philippines, I'm taking care also India and Middle East. Let's go to the contents. first I want to explain about EXI, then explain also required and attend EXI. That was already Philip's presenter is already explained, but might be a same portion, but I just want to review it. Then also how to achieve the required EXI, then how way of EPL. I think this way of EPA also explained, but from the engine maker, as an engine maker, I explain again. About the EXI, EXI is an engine efficiency existing for the existing ship index. Then it is required for about over 400 gross ton vessels. It is actually applied for international, from 2023 international voyage. Actually, I think that in Philippines, it's not applied. Philippine domestic vessels is not applied this EXI yet. But I believe Mr. Lei, he's requesting this EXI as a topics from each class certificate and engine makers. So it means near future, Philippines domestic also maybe apply this EXI. So like SOX regulation. Yeah, SOX regulation also 2020 in the worldwide start, but in Philippines 2024 just last year start apply that one. So maybe EXI also in near future apply in Philippine domestic market also. Then about EXI is for existing vessel. This can see. Yeah, first this is from class NK side. Check the vessel is ship has attained ED or not. Building is basically built ship build date, but actually just simply the vessel is roughly 10 years old. Then you can judge if the vessel, your vessel is have the EEDI or not. Then if your vessel is already have the EEDI, then you can use your EEDI and attain EEDI and EXI. Then if attained EEDI is less than required EXI, then your ships already comply with EXI requirement. Then if not, then need to modify it. But I think almost a vessel built after this period, almost vessel is not required any modification. But if the vessel is not have the EEDI from the first, that one is need to calculate attain EXI first. Then attain EXI is if less than more than required EXI, then you should need the engine energy efficiency, improve the energy efficiency. Yeah, like shaft limitation and engine power limitation. Then installation of the energy saving device, then fuel conversion. Yeah. Then this portion also already explained from previous presenter that how to calculate the required EXI. Just simply that formula is CO2 and SFC and engine power and capacity and engine EXI speed. But this is formula. So just consider about this one. Then actually how to achieve the required EXI is of course vessel need to improve the energy efficiency. Then probably most of the case is vessel owner is go to the limitation of the main engines. Because as you can see, this is our shop trial data. As you can see, the load is 100. It's then fuel consumption is higher than 85% and 75%. So it means then also fuel consumption per kilowatt also less than the 85% and 75% is less than 100%. We use this margin to engine power limitation. Engine power limitation is engine power limitation is later I explain. But we use this margin. Then about second item B, installation of the energy saving device is it might be costly. If hull design or retrofit some other devices is quite costly, I think. Engine power limitation is just limit the rack, so fuel rack, so it's very easy. Then, third one is fuel conversion to low carbon fuel. To use new fuel such as LNG and methanol and ammonia, engine need to be renewed almost, or very critical modification is required. So in such case, number C, this C item C is almost not impossible. Then biofuel can use for EXI. I'm not sure actually, but for the biofuel also, biofuel can use any modification. But biofuel also price and availability problem. So in such case, it's better to go engine power limitation directly. Then engine power limitation is common to achieve the required EXI. Then way of EPL is first calculate the attained EXI and require difference of the attained EXI and required EXI. But it's normally done by a constructing agency like a shipyard or class certificate. Yes, then please consult with consultants agency. Then also about the EXI technical file and onboard management manual documents also. Yeah. Then please inform us the EPL value. First, consulting agency such as shipbuilder and our class is calculate this difference of the attained EXI and required EXI. If we know that's the value, it's called EPL value. We can calculate calculate from the value how much the fuel rack need to adjust the EPL limit. Then in Daihatsu case, our case, we will provide below also EPL letter, limit letter, and instruction for the setting procedure, EPL limit, and cable lock sealing, and bolt with hole, then nut and genuine certificate. And I want to show you the sample of this one. This is a genuine certificate spare part. This is just sample, sorry. Repeat. This is engine model 6DKM 36. Then standard value for is 40 millimeter. Then power is kilowatt is 3,300. Then EPL set value is 34.1 mm. We calculate this difference, this value, how much you need to limit. Then we also provide a cable lock. Then each cable lock has a serial number. This DA001 is a serial number. Then the management list also will provide same. If in case the vessel need to more energy, like a vessel sailing the sea, then you need to avoid the small vessel, like a small fishing boat. In such case, then full astern or full ahead is required. In such case, you cut the EPL, this EPL. Then, but after cut the EPL, you need again after emergency occurred, then you need to install the EPL. Then you need to record the usage of the EPL. Then also, Daihatsu will provide the EPL limitation instruction manual. Like this. Yeah, we will provide like a same as man. Manually limit. Of course, we also can provide our technical engineer, but maybe a customer can set it by themselves with this procedure. Then, in case of the vessel using the electric camera, like a nav telescope, we also provide how to limit by electrical camera. It's just sample. Then we can advise how to adjust the engine power. Then also we provide the genuine certificate. Like this one. So not genuine certificate, like a letter we provide. Okay, I go back to the slide. Yeah, we provide the bolt with hole. Then we provide cable lock. Then you can lock the F4 lock. Actually, that's it for presentation. Yes. For engine maker, the EPL is EPLs, yes, need to calculate by owner side, consult with agency, and if you know the EPL value, we can calculate that fuel rack limitation. So, but in case if you have such require, please let us know. We can help you as much as possible. Thank you very much. That's it for my presentation.
for the next presentation, we would like to call on one of our valued sponsors from Draeger, Singapore, to present safety hazards on alternative fuel for carbon intensity indicator or CII rating. Let us welcome Mr. Yu Yong Horn, the Government Key Account Director, Singapore. Let's give him a round of applause.
Okay, hi, good afternoon, everyone. Hi, that's meant to wake all of us up at this time of the day. Okay, I thank the organizer for this privilege to share a little bit about the company. Draeger has been trying to grow into this maritime business in the Philippines. So today is actually a good opportunity for all of us to get to know each other. Because I know that in this room today, many of you are from the marine and technical and also some of the consultancy with very much interest in the maritime industry in Philippines. Of course, the topic that I just want to introduce about Draeger today, it's not exactly related to what you are doing in this session, but again, it's a bit related because as you talk about alternative fuel, then maybe you should also consider things about some of the hazards behind it. But some of you may have seen my presentation before because this is my many attempts to introduce Draeger in this country. So my name is Mr. Yu. Yes, I'm from Draeger, Singapore, but I'm here to support our branch office here in Philippines, which is Draeger Philippines Corporation. You get to see the team later on in the presentation. So without not too much delay, I will just start the presentation. That's it. Come here.
We interrupt your regular broadcast to bring you this important.
One of the questions always asked is, why are you running in and everybody else is running out? That's a good question. Very good. That's fine. That was a good swing. And when you leave the house in the morning, there's that question. Are you coming home? And there's always that possibility that you're not coming home. What is more dangerous? Is it the fire or is it the smoke? And typically a child will say the fire, but that's just not so. So for us to have the ability to have a breathing apparatus to get in helps those to get out. Ich bin gebürtiger Hamburger, das ist ja fast ein aussterbendes Ding. Also Sicherheit geht alle an. Ein Shutdown wird bis zu einem Jahr Vorlaufzeit geplant. Wenn eine Prozessanlage nicht sicher wieder angefahren werden kann, dann haben wir große Probleme. Was mich persönlich bei der Firma Drege überzeugt hat, ist die hohe Kompetenz, auch kurzfristig Lösungen herbeizuführen, die wir so alleine gar nicht hätten wuppen können. Das ist kein Tag, der deckungsgleich ist. Das ist auch ein bisschen Spaß bei der Arbeit. Und der muss was sein. Und man darf auch gerne mal ein Stückchen lächeln.
जे थोडंसंच ते व्हेंटिलेटरच्या एक साईडचं त्यात माझा असा हात घालून त्याला फक्त टच करायला ते एवढं लहान बघून मलाच भीती वाटली की एवढं छोटं बाळ असू शकतं त्यावेळी म्हणजे सुधारणा होती किंवा वजन वाढलं असं त्यांच्याशिवाय ते बाळ जगू शकले नसते
Die Leitidentität für das Leben. Es geht immer ums Leben, es geht darum, das Leben zu schützen, das Leben zu erhalten. Rega ist jetzt in der 5. Generation als Familienunternehmen. Die Familie, das Management haben es geschafft, Rega über diese lange Zeit auch selbstständig und unabhängig zu halten und seine ganz eigene Geschäftsphilosophie zu verfolgen. Das macht mir das Gefühl zu wissen, man produziert Produkte, die Leben retten. Und wenn man dann sieht, dass die Geräte helfen, dann macht einen das schon stolz und das ist ein schönes Gefühl.
Because that's to show you that Drega is not just a safety company, but we're also doing a lot of medical business here, right in the hospitals, even in the Philippines. So one of the greatest remarks made by our CEO, which is Stefan Drega, he always put that everything we do, and we want to do with passion, and we do it for life. And it's exactly what Drega is all about, how to save life, and how to keep everyone safe. So this is a bit of history. As you can see from the video, we are a pretty old company. As of this year, it's 136 years old. So you can see that many generations of leadership that's handed down. Right now, currently, is Stefan Drega. So what we started out many years ago, in 1889, doing what we call a Lubica valve. But what's interesting about this valve, it has nothing to do with medical, nothing to do with safety. He started to produce a valve for the beer tap system. As all you know, Germany is famous for beer, and that's how it started. But with that humble technology, they start to use into providing means to control the anesthetic machine, as well as in mine disaster. Right here in Philippines, you have a lot of mines whereby we build respiratory to help the miners go in to save others trapped, and subsequently we start to develop many other technology over the years. So Dragon today, as of today, it's a company has grown. In the video just now, it shows about more than 10,000. So currently, it's about 60 over 1,000 staff worldwide. We have now grown to about 3.3 billion euro company. That's almost 4 billion US dollars. So Stefan Drager is still the current CEO as well as the chairman. And we have offices all over the world. As you can see, we have also Philippines right here in ASEAN. Right over here, you can see that's Philippine office. And this is our team right now. Not small, but not big also, but the team that's been around for the last 7 to 8 years supporting the industry, and of course including the maritime industry. So our market, as you can see from the video, so we talked a bit about fire services because that's where the breathing apparatus is being used. And the same thing, breathing apparatus are also used in the maritime industry. And therefore it's made to a certain standard, not just to provide breathing air, but also to comply with all the various flame tests and drop tests, as well as to be able to withstand a very tough environment. So in terms of fire services, we have one of our main focus. So it's there with all the fireman helmets, thermal vision cameras, stuff like that. As for the mining industry, we have even improved technology over the years to help the miner to breathe longer. Typical breathing apparatus lasts you maybe about an hour, but with the mining, the breathing apparatus can last them up to 4 hours to help them to go inside to save miners who are trapped and to rescue them. And of course, for mining itself, we also provide a lot of other means of shelter so that in case miners are trapped, they also have means to be safe. And one of the other focus of Drager is to how to reach this Vision Zero. In some of the industry, Vision Zero is become a critical target to how to reduce accident in workplace. So the same thing for the maritime industry, we also want to make sure that the crew are all kept safe in their journey on board, working on board the ship. So we do take responsibility, and then as a family entrepreneur, the things I do, which is Stefan Drager, I want to be able to explain to my children tomorrow. So we believe that we need to leave behind a good legacy. And the things we do for any industry, we want to make sure that we are able to pass it down to tell people the pride of our technology for life. So, of course, this will be the slide that most of you are very familiar with, whereby we are in that transition whereby the alternative fuel may be something that will also help to improve the carbon intensity index. This is where we believe that as we go into new era of clean fuel, we also need to be mindful of many other risks that we are dealing with. So in the maritime industry, as we are transiting, we have to be mindful of the danger. Now the next few slides I show has nothing to do with clean fuel, but to suggest that there are dangers and risks if we don't take care of it. Such as this ship that we thought, as it was safe because we're talking about electric vehicles, right? All these years. In the modern time now, many countries are adopting electric vehicles, and I thought everybody is, we want to make sure the environment is free from smoke. We introduced EV, but EV battery has this problem that led to fire on board the ships. So as of even recent, you can hear there were vessels that are right now near the North Sea where they are trying to deal with another disaster. Then this is also another case of facility ACE also that as a result of the electric vehicle that led to a fire on board the ship. And how do we deal with it? This is also an ongoing topic, how the maritime industry have to be prepared to deal with such emergency on board the ship. But today, of course, we want, as we talk about clean fuel in this, that will affect your improvement in terms of your carbon intensity index. We also want to highlight to the members here technical team here and even the Marine Superintendent talked about the potential hazards of clean marine fuel. And so the question we should ask ourselves is whether clean marine fuel safe when it aims to give us clean air. So this is a thought-provoking question for you to think about, because as we go into it, there are actually potential safety risks for clean fuel-powered ships. And one of the things that we may think about that there are potential serious pollutions, highly toxic fumes and clouds, and also major fire incidents. If everything is under good control, we are in the right direction, because what we want to achieve is good efficiency for the ship, at the same time to have a cleaner air, but at the same time we must make sure this does not happen on board the ships. So we talk about in the evolution of this alternative fuel, which is already ongoing. We know that many ships are already LNG powered, and for LNG ships, LNG gases itself, there's potential for asphyxia because it's heavier than air. It's cryogenic exposure if you are near a leaky pipe. It's of course highly flammable that we have to be very careful with. Of course, the potential for pool fire if it leaks and how it can lead to more serious situation is beyond control. Now, for other alternative fuel, also we are ongoing. We see methanol coming on stream now, and there are actually serious cases where people, if you are exposed to high level of methanol, you will be potentially cause blindness also to the crew. So at the same time, one of the risks, if a fire do take place for methanol on board a ship called methanol fire, you will also have problem, because in the daytime, in the daylight, methanol fire are pretty invisible to the eye, to the naked eye. You can't see the fire. So how do you fight a fire if you can't see the fire? But of course, there are solutions today to deal with that. And of course, it's also highly toxic that we need to watch out, because at about 250 ppm, this is where I talk about not just about consciousness, but it will affect the eye vision of the crew. So ammonia, it's also a big thing that's coming up. Of course, ammonia, one of the major concerns of ammonia is actually it's highly toxic for exposure, and it's basically something that can actually cause fatal death. So hydrogen, of course, is another one, but one thing, although it's not that toxic as some people may think, but highly explosive, because for hydrogen, you just need a small spark to start everything. So again, many controls must be in place to make sure this all does not happen. Biofuel is more about pollution. If it leaks into the sea, then it causes pollution that will affect the marine life also in the sea. So, what can we do to keep everyone safe on board? So of course, safety engineering is one of the things that many of the companies are already thinking through how to, when we start to introduce all this fuel, what are the things that you need to look within your organization, within your ships that you manage in terms of ISM. So it's important that we look at various consideration of gas detection, which should be supported with breathing protection. Because when you talk about engineering control, you need to also evaluate the risk behind when we are dealing with all this new alternative fuel. We will also have to consider equipping the crew, how they would to deal with that. So these are some suggestions of how we can be more prepared. Of course, we all have to be familiarized with the new IMO safety regulation. More and more rules are being in place to handle this new fuel. It's not official mandated yet, but a draft copy has already been released. So we need to really how to be prepared, be familiar with the various regulations. Of course, training. I think Philippines is well positioned, a country with many qualified training institutions or training academy. This is something that the training school also have to think about how to train the crew to deal with future kind of potential safety hazard on board the ship. You then, of course, can talk about how you can upskill to manage the clean fuel through various expert and consultancy companies that will help your organization. We talk about training exercises for new processes, drills on board the ship to be thoroughly familiarized with our risk assessment of all these safety hazards that will happen, could happen on board the ship. Regular health screening, because you do not know if you are exposed for a long time, what kind of health effect. And of course, one of the things that we always emphasize that you may have the right equipment on board the ship, but it's also important to observe strict maintenance of the safety equipment, because safety equipment are there to protect your life, and therefore you have to make sure that the equipment are fully functional to serve its purpose. So this is a suggestion of what Draeger does. Draeger has different type of breathing apparatus for different industry. For the maritime, we make sure that our equipment are also approved to SOLAS. So you have to also think about the fact that you're dealing with many different types of clean fuel. You also have to think about whether they are not just fire resistant, but also chemical resistant also. And one important factor about SCBAs that you have to consider is whether the full face mask fits your crew on board. This is something not practiced, something that is not really regulated, but we will always recommend companies to consider doing proper mask fitting to make sure that the gas don't leak into it. Even though SCB provides what we call positive pressure, but it's also important to make sure it fits well to you so that you can maximize the duration of the air. Because a leaking mask will basically cause the air pressure to drop very fast, and therefore your duration of air will be very much later. Some of you have been sailing before. If you have used the SCBA, you will realize that even in a simple 30 minutes SCBA will only last you about 15 minutes, because you are breathing so hard that you are not conscious that the air is running out very fast. So unless you go through regular training like the professional firefighters who are trained every day how to use a BA set, you do not know that you have put yourself in risk, and therefore it's good to be able to know, to make sure that the SCBA face mask fits your crew to minimize any air loss. Then of course, besides the SCBAs, you have to think about fireman helmets, and one of the things that slowly introducing into the marine industry is what we call BA comms. BA communications are used on board many of the new ships right now, because they find that when they actually deal with situation in a fire or in a chemical leak situation, they can't understand each other. You could not understand when you try to talk, even though there's a speech diagram, you cannot understand each other. So communication plays a vital role for the fireman or the crew on board to be able to communicate clearly. And the next one would be the thermal imaging camera that is fitted on the face mask. This is one of the available technology nowadays, latest in the market, whereby we mentioned about methanol fire, because it's invisible during the daytime. If you're the one trying to address methanol fire, you need a thermal imaging camera. So this is one solution whereby you can mount inside the face mask so that the firefighters can see where the fire is themselves. Of course, then the next thing, you need chemical suit to also protect, especially those that maybe have good, not just for chemical protection, but you should also probably consider whether the chemical suit can be able to withstand the low temperatures such as the LNG. Of course, one consideration is to make sure your chemical suit have a long shelf life. Okay, last thing, but one of the things that you want to consider is that on board many of the maritime industry, more and more people are actually using Draeger tubes. That this is a low-cost way of monitoring the hazards on board the ship. If you want to know more about the Draeger tubes, please come and visit us at our booth later on in the hall. And of course, for anything to do with toxic, you need the gas detectors also, both single and multi-gas detector. And one of the things that I want to always emphasize to the user, buy a detector that gives you reliable sensor and accuracy. And one of the important factor about gas detector is the response time. Make sure your sensor is able to respond time within the less than 30 seconds, and better still less than 20 seconds, because by the time you are aware of the gas hazard, it may be too late for you to respond. So it's important that you have been alert in time for you to respond. And the next thing consideration is sensor life, because the sensor life itself allows you to minimize your cost, as in the total cost of ownership can be then. So not forgetting that in the various solution on board the ship, you may have to consider things like fixed gas monitor to be able to see and monitor the situation, especially right now with all these EV vehicles. You may want to consider how you may want to have flame detectors to be able to give you advance warning enough to respond. Because by the time the thermal run runs out, it's very difficult to stop the fire. So you'd rather be able to catch it before it becomes too big. So with this, I end with another video that talks about outrigger gas detection.
Enter Damon Shipyards in Galați, a renowned name in the maritime industry, situated along the majestic Danube River. Within these yards lie potential hazards, particularly related to the presence of hazardous gases. Shipbuilding involves various processes such as welding, cutting and painting, which can generate combustible gases such as hydrogen, acetylene and methane. Certain materials used in ship construction, such as paints, solvents and insulation materials, can emit toxic gases such as volatile organic compounds, VOCs, formaldehyde and carbon monoxide. Prolonged exposure to these gases can cause respiratory problems, neurological disorders and other serious health issues. Without proper safeguards, all these hazards can materialize at any time. To prevent such occurrences, Dregger offers custom-made solutions to address each of these potential hazards. Dregger's wireless gas detection solutions, such as the
I think it's okay. But I tell you what, because there's maybe a bit technical fault behind the video. But those who are interested, yeah, feel free to come and talk to us. We can share the video we have. But for this slide itself, if you are able to scan the QR code, there is a white paper to talk about handling this methanol fuel in the hydrogen economy. You just need to fill out a form and then you can download it free of charge. Okay, with that, thank you very much for listening to this short sponsor presentation. Come and visit us at booth 125. If any of you got any other question, please come and see us. Or if you think that the slides can be something that of benefit to you, come to us. We can get you a copy also. Okay, thank you.
Mr. Horn for that presentation. Continuing with another key engine manufacturer in implementing the EEDI or EEXI, we are joined by representatives from Myanmar Asia Singapore Corporation. Please welcome Engineer Nigel Eric Fundal, Assistant Section Manager, and Mr. Ricky Chen, Section Manager. Let's give them a round of applause.
So good afternoon everyone, ladies and gentlemen. My name is Nigel from Myanmar Philippine branch. And today I'm going to present to you about our business and directions for the next alternative fuels. As we know, IMO adopted the initial greenhouse gas strategy in 2018 as a carbon neutral plan for international shipping. In this strategy, the target is to achieve zero emissions by 2050. However, this strategy may change and we expect green reductions to be implemented earlier. This is due to the recently many countries have declared to achieve carbon neutral by 2050 and the target of 50% greenhouse gas reduction by 2030. So this slide shows the forecast for alternative fuel conversion by each classification society. As we can see, the forecasts are different by each society. For example, DNV expects LNG accounts to be 40% as 2050, and ABS expects conventional fuel to account about 40% as of 2050. This indicates that it is difficult to decide which alternative fuel will be the main, and this forecast may change because of the IMO's view on greenhouse gas strategies. So this slide shows the solution for zero emissions based on power output and cruising range of the vessels. For vessels with higher output and longer cruising range, methanol and ammonia are suitable. For boats and ships with lower output and shorter cruising range, fuel cells or battery systems are more efficient, or more suitable. For vessels and ships with medium outputs and short cruising ranges, hydrogen engines are more suitable. Therefore, we are not able to judge the main alternative fuel that will prosper. So, with that, Myanmar is developing new technology for alternative fuels, and we want to be ready for any alternative fuels that may come. We develop alternative fuel technology for biofuel, natural gases, methanol, ammonia, and hydrogen because suitable alternative fuel depends on the ship type, the cost, the availability, and the time. In this situation, we are developing alternative fuels technology in all directions. So I will be introducing to you our approach for each of this alternative fuel. First is the biofuel. So in 2007, Myanmar set up a biofuel research center in Kota Kinabalu, Malaysia, and we have been working on research and development for the practical application. We have evaluated FAME, which stands for fatty acid methyl ester, and HVO, hydrotreated vegetable oils in test benches. The slide figure shows the test results. And for HVO, all the test results are same with our diesel oil. For FAME, fuel oil consumption is worse than diesel oil because of the lower calorific value. Fuel injection pressure of FAME is higher than diesel oil because of the higher viscosity. On the other hand, exhaust color is better than diesel oil because FAME contains oxygen. So next I will introduce the result of the ship test on the biofuel with one of our customers, Toyota Chuho Corporation. This test was carried out in Singapore and the main engine was 621 EW. The fuel used was B50. Running time was around 2,000 hours. So far there were no problem with the engine running smoothly. So currently, Myanmar have many experiences on biofuel trials. So if you require more information for the Myanmar engines with biofuels, you can request us to share our service news for that particular topic. So next one is LNG or liquefied natural gases. So we commercialized LNG dual fuel engines in 2016, and currently we have a lineup of both main and generator engines. LNG fuel is better fuel for emission because it can reduce SOx and PM, NOx, CO2 compared with the diesel fuel. In addition, dual fuel engines has high adaptability because fuel can be switched between natural gas and heavy oil depending on the operation area. So this slide shows the development of our dual fuel engine. We developed 6EY G26 in 2014, yeah, which is a marine gas engine, after which we developed the EY26 dual fuel engines in 2016. In 2022, we released the 6EY22 dual fuel engine based on our 6EY22 diesel engine. In addition, we are expanding the output range of our EY22 dual fuel engines. So we are developing higher power model of 6EY22 dual fuel and 8EY22 DF engines. So by increasing our output, 6EY22 DF engines output goes up to 1,265 kilowatt, and our 8EY22 goes up to 1,680 kilowatt. So this slide currently shows the lineup of our dual fuel engines. So currently we can cover the output range from 800 kilowatt to 4,000 kilowatt. So here is our LNG DF engine adoption examples. Upper pictures are tugboats and bunkering tankers, which are equipped with 6EY26 for their main engines, while lower picture is ferries, which is equipped with 6EY26DF for their auxiliary. So the dual fuel engines are running well on these vessels. So the next one will be on methanol. So this slide shows the characteristics of methanol fuel. First is liquid at normal temperature and pressure. So methanol have an advantage being stored and bunkered. Second is fuel tank capacity is 2.4 times heavier than heavy oil. So this means methanol can be stored in a small capacity. And third is oxygenated fuel, which means it can reduce soot. Therefore, methanol is suitable for large ships because of these three advantages. So here, let me explain the combustion method of the methanol engine. So we consider two types of combustion methods: low pressure port fuel injection or PFI and high pressure direct injection PI. So injection system of low pressure PFI is like dual fuel engines. This system has two injectors at intake port and cylinder head. Methanol is injected into intake ports to mix the air and flow of the cylinder. Then after that, the fuel is injected and ignited. Following that, the diesel flame ignites the mixture of the air and methanol. On the other hand, high pressure DI system is having all injectors on the cylinder head. Methanol and the diesel fuel are injected at almost the same time. In this system, the combustion process is same as our normal diesel engine. So this is a video for the high pressure injection system, and on the right side is the low pressure PFI. So this slide shows the merits of each combustion method. The merit of high pressure DI is having higher methanol ratio with fewer limitations, while on the other hand, the lower pressure PFI is simpler than the high pressure. Lower pressure PFI has a possibility of retrofitting from our dual fuel engines. With that, the development period can be shorter, and we can contribute to the greenhouse gases reduction. Therefore, we focus on the low pressure PFI system to develop for our methanol fuel engines. Also, we are working on researching methanol combustion with single cylinder engines at our Research and Development Center. This graph shows the test results for maximum mixing ratio of methanol by cylinder bore size. This graph shows the test results for maximum. We already achieved the co-firing rate over 70%, with single-cylinder engine, and we aim to achieve the same or higher co-firing rate in the multi-cylinder engine. So we intend to launch the methanol engine to the market by 2026. And to start off, we plan to develop a 6-cylinder engine first. Hopefully, 6EY22ALDF-M will be released by June 2026. And then 6EY-ALDF-M engine will be released by the end of 2026. So we will bring the first methanol engine to the market in 2026 which is 6EY22ALDF-M and 6EY18AL-F. So this table shows the basic specs for both engines and their output powers. So our next topic for is the ammonia. So ammonia, first is the ammonia characteristics are first it remains liquid under pressure or at low temperatures, and carbon-free and toxic and corrosive. Since storage method is already established, ammonia is it gets a lot of attention from large vessels. However, there are some challenges for ammonia engines. First is that we must solve problems such as flame retardants, emission, blow-by, and corrosion. So we are working on researching for ammonia combustion endurance tests by using single-cylinder engines. So these pictures are our testing facilities for the ammonia engine. So testing equipment includes single-cylinder engines for safety system and fuel supplies. For safety, ammonia tank is located outside the building. In case for emergency, ammonia supply system will cut off automatically. Furthermore, we also catered ventilation system in case of ammonia leakage from the engine. So this slide shows results for the single-cylinder engine test. We achieved 95% ammonia fuel mixing ratio. So the upper figure shows the relationship between the fuel ratio and the N2O emissions, while the lower figure shows the relation between the fuel ratio and the increase of greenhouse gas emissions. So as you can see, at high fuel mixing ratio, N2O emission increases. As a result, the GHG reduction is suppressed to only 50% at 95% ammonia ratio. Therefore, N2O reduction technology is required to reduce the greenhouse gases. So this slide shows the image of the after-treatment system for our ammonia engine. N2 is generated by ammonia combustion and has a strong impact on the greenhouse gases emission reduction. NOx is generated from only pilot diesel, but nitrogen atomic, including ammonia itself, ammonia is difficult to combust, especially for higher engine speed application. Therefore, unburnt ammonia can be emitted. Therefore, after-treatment system is required for the NOx, for the unburned ammonia and the N2O gas. Medium and large engines. So this slide shows the high-speed medium hydrogen engine development project. This project is supported by Japan Foundation, and we plan to start onboard testing with this hydrogen engine from 2026. For large hydrogen engine development, we are taking part in the Green Innovation Fund project by the New Energy and Industrial Technology Development Organization. So in this project, we develop an 800 kilowatt medium speed engine and a 1,400 kilowatt medium speed engine. So we are planning to onboard testing for both engines, which is scheduled to be completed by 2030. So this slide shows the single cylinder engine test bench and liquefied hydrogen tank. The right picture shows the liquefied hydrogen tank at our Research and Development Center, and the left two pictures are the test benches for our. For safety, engine hood is installed in this bench, which is like ammonia engine bench. So if hydrogen leaks from the engine, hydrogen will flow out through the ventilation lines. So for the hydrogen fuel cell, so Yanmar developed a hydrogen fuel cell system, which is the first boat to be officially comply with the guidelines in Japan. So this shows the demonstration of filling high pressure hydrogen into the fuel cell boat. This demonstration was carried out at Osaka Port, Japan. So there is a mobile hydrogen refuel station, and it is usually used to refuel hydrogen cars. So high pressure hose connects to the shade station of the boat. So this shows our hydrogen fuel cell system. So the main specifications are as per listed in the table. So this system was commercialized in August last year, and we have delivered 2 fuel cells already for one vessel. So the operation of that vessel will start soon. So this is the vessel with the Yanmar hydrogen fuel system, and we have received approved in the principle of the fuel system by Class NK in last January. So let me just summarize our developing timeline. So we had already developed biofuel technology, LNG, dual fuel engines, and hydrogen fuel system. For LNG, we are working on the methane slip reduction. Field demonstration will be completed by 2026, and we will apply the technology to our dual fuel engines. For ammonia, we are still studying and start testing using single cylinder engines. And for methanol and hydrogen, we are developing the engine. We are still developing the engines. So hopefully we can introduce the methanol engine by 2030. So thank you so much for your attention. If there would be any questions, please proceed to our booth so that we can discuss further. And I will pass on the mic to my colleague, Sir Ricky Chen, for another presentation. Thank you.
Engines and generators of multiple vessels in the same account. So it is very convenient. The idea behind the remote monitoring service is to ensure that owners and operators can remain connected anytime, anywhere. It also allows the service team to provide support in the shortest time after receiving an email notification of an issue. So this is an overview of the system setup. An IoT gateway will be connected to the existing system of the engine and linked to the internet for remote monitoring. So these are the main functions of the remote monitoring service. First, owner and operators can view live engine status remotely, anytime and anywhere. They can also receive an email notification as soon as a problem occurs. Next, they can access a history of past issues. And these are secure and well-protected data. And finally, there's a customized remote monitoring service dashboard. Next, I will elaborate on each of the functions. So you can imagine you are the owner or operators working in the office. So let's say without the remote monitoring service, you will be left wondering about the status of the vessels. So this might actually make you feel stressed and even insecure. But with the remote monitoring system, you can use any device, a laptop, smartphone, or even a tablet, to actually view the live status data of the engine anywhere in the world at any time while connected to the internet. And with email notifications, as soon as engine alarms occur, an email will be sent to the relevant parties. These provide common understanding and reduces any communication downtime between everyone. Right away, with the owner's permission, the service team will assess the event history and investigate the problem, analyze the data, and determine the root cause of the problem. Then, service team will provide solutions and prepare a list of required spare parts for recommendation. All of these will happen at the same time. Finally, the dashboard for the platform is actually customizable. It can be changed according to your preference and project requirements. Now, you may be actually wondering how Yamaha's remote monitoring service relates to energy efficiency. So let me explain. Energy efficiency is actually directly affected by fuel consumption. So for example, we have a new engine model, APK200, which requires 150 gram per kilowatt hour at 1800 RPM. So let's say 1 year later, the same engine actually requires 170 gram per kilowatt hour to run at the same 1800 RPM. So what does this mean? This means that there will be a higher fuel consumption, a lower energy efficiency, and more CO2 release. So what increases fuel consumption? Firstly, a poorly maintained fuel injection equipment. This can cause injector leaks, a low injection pressure, and result in incomplete combustion. Secondly, issue with the lubrication and cooling systems. Higher temperature in the cooling system increase internal friction, leading to greater wear and tear. If lube oil is not routinely changed, it will degrade, causing an increase in carbon deposit and reducing airflow. Lastly, an increased engine load, often caused by incorrect propeller matching and fouling of hull and propellers. And finally, how does the remote monitoring service help? So the service itself provides real-time monitoring of both engine parameters and fuel consumption, helping to optimize load conditions. It also sends out email reminders for periodic maintenance, which help maintain engine performance and prevent excess fuel consumption. Lastly, when an engine alarm occurs, a warning notice is sent through email or text messages to the relevant parties. This helps to prevent and reduce downtime, thereby minimizing any energy waste. And yep, that's it for my presentation. Thank you very much.
Anytime, maritime!
Anytime Maritime.
Anytime, maritime!
Anytime Maritime. Anytime Maritime. It's Anytime Maritime.
Anytime, maritime!